All right, thanks, guys. We were running a little bit late, had a couple technical difficulties, but we're good to go now. So I'd like to introduce Benny Hill. He's a tech at the Oregon OCAC. Yeah. So he's going to talk a little bit about his laser cutter, final. There it is, and the Delta printer, and he's got a CNC router. So take it away, Benny.
Thank you.
All right.
You guys hear me all right? Cool. Just like to thank everyone for coming out. Any K-12 art teachers in the house? Yeah, you guys are my heroes, so keep doing what you do. We need you in this world. All the NCECA volunteers, West Virginia University, you guys have done a great job of setting up the clay FabLab. Luke, thanks for bringing in my equipment the other day, and I don't know if Ken's in here or not, but those guys have been awesome. Who else we got? I mean, just thanks for coming to the event. I know it's not cheap. It's not easy to fly all the way out to the Pacific Northwest. I hope you've enjoyed the time here, and it's a beautiful place to be. I came out here 6 years ago, and I absolutely love it. So I hope you're having a good time. There we go. I'm hoping that screen comes up here. So just to start off, I want to talk about how I got involved as an artist, as an art educator, working with technology. I saw this image about 7 years ago, and it really started to open my mind as to what my students were going to be encountering throughout their life and how important it was for me to start to teach some skills that students are going to need in the future. And so this is a little bit of a difficult graph to read here. I've got my little laser pointer. I don't know if it's going to work on this or not. It is 69.8 degrees. But this is a technology timeline, and what it's doing is showing the years necessary for an invention to be used by a quarter of the US population. Okay, so if we look at the telephone, it says on this graph here that it took 35 years for the telephone to reach a quarter of the US population. And as you see, as the graph goes further and further in time, these lines get shorter and shorter. And as we get up to the compact disc age, it took 12 years for a quarter of the US population to get their hands onto that new invention. So what does this mean? Obviously, technology's moving and growing at a very fast rate. We've all heard the exponential growth of technology. And I thought this was a great chart to kind of show how that kind of works. It's also a little bit, the graph really brings to light a quarter of the US population getting their hands on these tools. What's happening to the people not getting their hands on the tools is definitely something we need to think about. So another chart here. A lot of times in our life, we think the next generation will experience technology very similar to us, and that's not really true. As you can tell, nice. We got that nice curve, that exponential curve here, and it's not a straight line, right? So what I'm going to have on next, I'm going to show a video. It's a little bit humorous. I encourage you to go home and YouTube Rap News Singularity. Go YouTube this. There is a little bit of profanity in it, so if you got some young ones, you might want to beware. But let me set up it's a real short clip, maybe 15 seconds. It's a rap song about the singularity, which is something Ray Kurzweil, a futurist and inventor, has been talking about for some time. And it's talking about this exponential growth of technology. And the gentleman rapping is playing Ray Kurzweil. He has the wild white hair, kind of the mad scientist look. But get your listening caps on, because this rap is going to be pretty quick, but there's some serious knowledge being dropped in it. So we're going to also see how our audio is doing on this as well. So here we go.
The singularity? When is this happening? Next century? Please! You're thinking linearly. Technology leaps exponentially. Check the curve. A 10,000-year gap occurred between the harnessing of fire and the invention of the wheel on Earth. Only a century divides the age of steam trains and terabyte chips. Now every couple of years we get the next paradigm shift. So we won't see 100 years of progress this century. More like 20,000 on this trajectory.
So go check that out. I'm really worried that there's not enough people watching this video, so we need to get those the view count up on that video. And it's very humorous and explores how humanity has had an interesting relationship as technology is growing and how we view technology. So I'm coming from Oregon College of Art and Craft. I've been running the FabLab and opened it up a year and a half ago. It's been a real joy working at the Oregon College of Art and Craft. It is established in 1907. That's a long time ago, 110 years. And what's really cool is that just like, referring back to that video we just saw, a lot has changed at the school. And whether that be the photography department, the ceramic studio, new equipment has been coming in. We've got new saws in the wood shop ever since the early 1900s, and we've been growing with these tools. It's a beautiful campus just west of Portland. It was really fun to fly the drone around and get some aerial shots of it. And I encourage you to go check out the openings tonight. It'll be worth your drive up there if you can't get there during the daytime. The trees are starting to blossom, and it's just a beautiful place to be. So I highly encourage heading out there. We have a Bfa program with 12 different majors. An MFA in craft is a really strong program going right now. We have an MFA in applied craft and design. And next fall, I'm really excited about our MFA in industrial design. That will be something that is really going to be a big part of the FabLab. And I'm really excited about getting students into the lab that are going to the school to really innovate with these new technologies. All right, so what we've learned over the past year and a half is that these machines are only as creative as the people using them. And I can't really think of a more true statement than that. They will sit and collect dust very well if you don't use them, and they won't make jack. So you gotta get creative people using them. I run a lab, and I stole this from a high school shop teacher who said he had no rules in his classroom. And you're a shop teacher, no rules, chaos, all right? But we have procedures. So a procedure will be something that will protect the user, all right? It's gonna protect the equipment and hopefully keep the material from damaging the user or the equipment as well. I like to, I make an effort to create a culture of non-hierarchy. I'm not the end-all answer to 3D printing, laser cutting, CNC milling. I'm there to encourage students, bounce around ideas, and really foster that creativity that the students are coming to these machines with. And we are not a print shop. There are some universities where you will submit a file to the FabLab or whatever it may be called, and you come back a couple days later and you receive your object. I do see value in that system. That is how some of the real world works. But in a small school like OCAC, we really encourage students to know the entire process. And what's really powerful about that is you can start to design with the machine in mind. There are huge limitations to all of these machines. And if you understand those limitations, you can create designs that the machine wants to make, there'll be a happy marriage between the design and the manufacturing of the object. So I think that is really key, at least in our institution. All right. Fear of failure is something I've brought up in my entire career as an art educator. I had 2 years of middle school and 4 years of high school art education experience, and on the very first day of school, I'd get up in front of the class and we'd have a conversation about, on average, how many hours of math have you taken since first grade? And we'd say like, I went to math every day from first grade to sixth grade. How many hours? Maybe an hour a day. We do a little math on the board. And this is an average of what we would come up with. So on the first day of ninth grade, a student has had 1,440 hours of math, reading, writing, and education. These are just, an average, not every student. But then that same student may only have 360 hours of art education. And it's scary to know that that number is actually going down right now. But this would put your ninth grader at a second grade art level if you were to compare it to the math scale. So it's really important that the student knows where they're starting from. We don't expect them to be mastering any of these things because they haven't had any formal education in it. And the way that works at OCAC is no student that's gone through the lab in the last year and a half knew that there was a FabLab when they signed up to go to OCAC. So these are not students that have been using computers to generate art. The lab was installed after they had applied to the school, and we've been able to work with those students and make some really amazing things. So I'm excited about the years to come where we get students who have had some experience in this. But I wanted to share with you that you don't need a user that has had past experience. Just like all curriculum, all studios, all types of education can be taught in a variety of ways. I think West Virginia does a really good job of having Boomer, Shoji, and Kelly. They're very different teachers, and they can connect with different students in achieving a goal. And so having a diverse teacher setup or environment where there's multiple resources that can teach in different styles can be really helpful to your student population. All right, every classroom is full of individuals. So if you have people that can help out that have strengths in one area or another that can be a resource, that can be a very powerful thing. So having those teachers, and it doesn't have to be a teacher. All right, having a classroom where students may have a very technical mind, whereas you have other students that are very playful. If you actually team those up, you can get really nice results. Really great book, Daniel Pink. It's called Drive. What gets me really excited is when I see students self-investing in their work. And one way that it can happen is if you set them up for success. And one thing these tools can do very well is they have a large, what Daniel Pink calls the zone of proximal development. And this is where we've all played video games, or we've played a board game where it was too easy, where something was too easy, and it just wasn't fun, it wasn't challenging, and you quit right away. All right? And then there's the other end where it's too challenging, you can't get anything done, and you end up quitting very quickly, you don't get the point of it. I feel that these digital tools that we're working with right now have a really wide zone of proximal development. There's a lot that can be done as far as teaching strategy and in making it more simple for a user to create on these machines, but you can be pushing that student as well to go all the way up to building the machine and writing the code for the machine that's doing it. So there's that zone is a real nice area. As we go into accommodations and differentiations, I talked a little bit about this. All of our students have different learning styles. These tools can be taught very differently. I teach very playfully. We experiment a lot. What will happen if we do this? All right? I don't know. All right? So I encourage students to really experience the process. In my early art education, I learned that process was more important than product, and that's near and dear to me. So I love the process, and the more making that can be happening, I feel the more learning is happening. This requires a lot of failure because we are playing, and that's not for every student. All right, there are the students who need to really nail down a design, know the exact form. All right, run the test, and get a very accurate product from the very get-go, and not have quite as much failure. All right. So I am going to go through, I made a video up here, and this video was shot at Oregon College of Art and Craft, and it's going to show the process of the cups that I handed out and that I have up here. And we're going to have a little, I'll talk you through the process as we go. So, we start off in the ceramic studio by mixing up our plaster blocks. One really cool thing, and you'll see this throughout the video, is that the FabLab is a hub for students that are working in all different disciplines, and it requires you to leave the FabLab to go to a different studio. In a bit, I'll be going to the wood shop, but this requires students to actually interact with other students on campus that they may have never encountered if they weren't involved in a digital project. We can't be pouring plaster in our FabLab, it's too dusty. We don't have the facilities for that, so it's required of them to do it. I designed this cup in Rhino. What you just saw, that last shot was, there's some failure right there. We're running Aspire, which is by Vectric. That's our CAM software for our router. This is our ShopBot router. That's 48 by 48 inches with a 12-inch Z. I'm carving this with a 1/4-inch end mill. I believe I'm going spindle speed, 10,000 RPM. Feed rate, I believe I'm at 200 inches a minute on that one. Pretty quick cut. We're milling the plaster when it's wet. Yep, wet plaster. You saw it all kind of muddy and gooey there. I'm using a power washer to get all that plaster out. And then I go into the slip mold process, which many of you are probably familiar with. If not, it is a really fun process to do. This was my first time making slip molds, and I got really into it so much that I just made cups for everyone, right? So it was a lot of fun.
Why wet plaster or damp?
I haven't tried dry plaster yet, but I wanted to keep the dust level down when I was milling. That's all I got. We use a really trashed bit. It clogs up real quick, so don't worry about a special end mill. It really just gums up and we let it ride. Sometimes we'll clean it out every 5-10 minutes, but the cut I did here was I just let it ride and it worked out all right. These are our awesome Blau kilns in the ceramic studio. This robot's completely selfish. Do you see all that unfired work behind him there? Guy's a jerk. So we're gonna use two techniques to glaze this cup. The first is a vinyl cutter. Sarah Wolf is right over here on the end. She's gonna be showing her cups off that she's been using vinyl resist is what I call it. And this is the vinyl process you're seeing right now. This is called weeding. You weed the material out, and then you use a transfer tape. Place that on top. Plop it on your cup there. Head over to the ceramic studio. This is just an Amco low fire underglaze. I have this cup up here by the laser cutter. You can check it out after the talk. We have a rotary tool. Call this the Rotisserie Glazier here. It can work with cylinders and rotate the cylinder. This design was made in Adobe Illustrator. We're cutting on an Epilog Helix Mini. That's a 50-watt laser. I have the settings at the end of the slide if you want to write the settings down. I'm laser engraving a bisqueware that has had underglaze brushed on top. And Matt will be demoing the GlaZer. It is pronounced GlaZer with a G. Make sure you pronounce it right. And that'll be in just a few minutes. Matt will be doing that right up front. A little smudgy. I didn't get that great of a line on that one.
Why did you wait to feel it up?
I think it might have just been time.
Oh.
Yeah. So now I'm going into ceramic 3D printing. Used a 3D scanner to scan my head. My buddy scanned it for me. I went into Rhino, did a little bit of editing on the model, took it into Cura. That is the CAM software. CAM stands for Computer Aided Machining. And that's where you tell your machine, you know, all the specs it's going to need to know to generate the G code or general code. And we have a cup going right now that was designed by our new digital fabrication instructor, who's an awesome instructor. Her name is Diane Pfeiffer. She's doing a bang-up job at school. She works in a model shop. If you come check out the print that's going right now, it looks almost a little bit architectural. So check that out after the talk. You gotta be real careful once that's done printing. If you move it too quick, it might just fall right over. Here's a couple technical notes. Some of the smudging that I got was due to not letting the glaze dry. I got a couple people like, I knew that was gonna happen. I think I knew too, and I just wasn't patient enough. Oh, man. So let that glaze dry before you remove your resist. The GlaZer, we used Adobe Illustrator, as I mentioned before, 50-watt laser, CO2 laser. The settings are right up here. If anyone's got a laser cutter at their school, you should take a picture and I'd love to see what comes out of your shops. Yeah, Matt's been experimenting with some mason stains. We're still really trying to figure it out. We wanted to bring it to NCECA to encourage others that this is a possibility.
So the sample we got, that's just
that wasn't ran through the GlaZer.
Oh, okay.
That's just a clear glaze. Maybe we could throw it in though today. We'll see. We might run out of time, I think. Our CNC router, as I said before, is a ShopBot. ShopBot's running all right. It's good for an academic institution. There are some quirks to it. Of course, every machine that I've ever worked with has some quirks to it. I have never ran a CNC machine that didn't give me a little grief. So, spindle speed, 10,000 RPM. Feed speed, 200 inches a minute. And the plaster we're going to mill today on the little desktop, that was poured last night, so 12 hours maybe. You guys can see how that looks. Our clay Delta printer that's running right now over here. what we're doing to mix our clay, I know there's been some questions on like the consistency of the clay that you're putting into the Delta printer. We're taking like a 25-pound pre-mixed bag of porcelain that is in the pottery studio, and we're adding, I open the bag up, and I'll take a toothbrush, whatever, any kind of brush, flip it around, and start stabbing the block, right? Get a whole bunch of holes in it. Then I'll take 10 cc's of Darvan and just kind of put it in all those little holes. Then I'll pour in 2 to 4 cups of water. This is going to depend on what kind of form you're printing, how you want the clay to come out of the extruder. There's a lot of different ways to print with these ceramic printers. This is just our recipe. Keith Simpson is the man when it comes to figuring out some of the viscosities of clay, and I would encourage you to check out his work as well. So we let that 2 to 4 cups sit overnight, maybe 24 hours. You come in and rip that chunk up into about 3 parts and just get wedging. And you're just going to wedge and wedge and wedge and wedge. And what I do after we wedge is we'll build up a mound. We take the cartridges and we just plop it in and squeeze it all the way down as far as we can and break it off. I know there's a method where people have been using a spatula and like slowly feeding it on, and I just couldn't do it. And so things that we are going to sacrifice by doing this method, we may get some air bubbles. If you're lucky enough, we might have some blowout today on this one. We've actually been really successful in the last week or two of very minimal air bubbles. I haven't heard anything. Have you, Matt? It's not going well? We're failing fast, and that's good. You guys will get to check out the consistency over here. Really important thing. Do not run, if you're using the cartridges that we have on our Delta printer, let's not run those over 100 PSI. We've had the green top pop off on us before, and there's been a couple colleges that I've talked to that actually had the canister explode on them. So that can be extremely dangerous, and keep that PSI. I'd suggest around 80. I think that's what we're running right now, maybe 90, but nothing over 100. So this was the cup that got ran through the glazer. The orange did not really pop on it. We did get some nice lines. This is a trick I saw William Daly about 6 years ago, and he was giving a lecture at SOFA Chicago, and he says, this is how you shoot your pottery, right? When you're taking photos of it, you get the good side, because the other side may not look as good. And this was like, we just finished shooting this, and I had just wiped all the glaze off, and like, what's this looking like? And I was like, let's get the camera, and let's put it on the electric wheel, and let's turn on the wheel, and get a shot of this like with a nice slow spin. I think some of you might know what happened. So always check to make sure your electric wheel pedal is not down. When you turn on your wheel, it will throw whatever is on top of it off, and you could hurt yourself too. So how many people have done it? How many? Okay. Whew. You guys are making me feel better. The ceramic print that I did, I have the example up here. I did a double glaze wall is what I'm calling this. And I have a video of how I added a double glaze wall onto that ceramic piece. Went to a hot shop and blew a giant bubble of glass around it. Gary Botker works up in Vancouver, Washington, and he's down to experiment. And the wonder of that dog and curiosity is something that's interesting to me. So just want to thank you all for coming out. And what we're going to do next is get the GlaZer running. I'm going to start up the router. It'll be carving a slip mold. And Matt and Sarah will be here to field more technical questions that you have. And just thanks again for coming out.